Right. Hello, everybody. Welcome to the first lecture of ETCS5021. In this lecture, we're going to kind of talk about an overview of just computing in general, not anything specific just yet. That'll come shortly after. So where I wanted to start this journey is just talk about what is the goal of programming. Um, it gets kind of a bad rap sometimes as you're a coder, but it's really a lot more than that. Programming is taking any kind of idea about anything and producing some kind of tool that others can use. And there's a lot of forms that could take. It might be a website, it might be a app on your phone, it might be a video game. It's near and dear to my heart. Some kind of data processing utility, for example, you work with Excel files. How do you convert it to some other kind of file format? Might be a point of sale system. So if you go into the grocery store, retail store, somebody has to write the software that runs those things. Might be something as big as a company database. Uh, Internet of Things is a really cool thing that I'm interested in personally. Smart devices, things on the edge of the cloud, and really kind of anything else. So you name it, it's a tool that you can make. Somebody has a cool idea for it. And really the big question is, how do we do that? How do we make that thing a reality? And one approach that you could take would be to write machine code. So if you look at something like this is actually a hexadecimal dump of the Notepad program that comes with Windows. But this is what it looks like at the machine level. And I won't get into the detail just yet, but these are a bunch of numbers, and there's CPU instructions for a range of things, but a range of really, really simple things. So there might be CPU instructions for moving a number back and forth from some kind of storage device, some kind of CPU instruction to add two numbers, subtract two numbers, maybe multiply and divide, put those in brackets because not all machines actually have the hardware to do multiply and divide. Comparing numbers, uh, taking the result of that, jumping from one point in the program to another. That's really all a program is at its heart, is those simple CPU instructions. They're really specific to a particular architecture. You might have heard of a couple of these. The x86 is a really popular general purpose computing architecture. Atmel, Tegra, there's a bunch of different hardware manufacturers. Most people would not choose to develop a tool in this kind of environment just because it's very specific. It's hard for us to look at that and understand what's going on. So early on in the days of computing, computer scientists realized that that's not an ideal form to develop programs. And what kind of came next after that was assembly programming. And this is still very tightly tied to a particular architecture, still those low-level CPU instructions, but easier to read. For one thing, there's a bunch of comments in this little snippet of assembly program that I've picked out, but still, each one of these things is a simple CPU instruction. This is actually from a Atari 2600 tutorial. Okay, but assembly is interesting because it's a text file that a human could read and write, and it's easily convertible to machine code. Okay. It is still used a little bit today. So back in the early days of console development, I'm a game developer, so that's again near and dear to my heart. That was what was used for Atari 2600 NES development. Even today, though, device driver writers. So if there's a new piece of hardware, like a flash drive on your computer, somebody has to write the device driver for that, and they will use assembly for that. Compiler developers. So in the next lecture, we'll talk about interpreters and compilers, and somebody writes those. A lot of times, at least a portion of that is written in assembly programming language. But most of the time, when you think of programming, what you're really thinking of are so-called high-level programming languages. So the idea there is that we still have some kind of human readable source code, this bit over here, and then it gets fed into either a compiler or an interpreter. They're a little bit different. The end goal with both of those is to get those instructions down to the machine code instruction, but they're more generic. So you could write a Python or a C or a Java program on one machine architecture, but then it can be ported pretty easily to other architectures. The little bit of a difference between these two, compilers generally produce some kind of standalone executable. Interpreters usually have to have some kind of tool that runs alongside of it. Kind of the trade-off there is that compilers and these executables tend to be a little bit faster, but if something goes wrong while they're running, you don't get as much information about what went wrong. Interpreters just the reverse of that. We're going to use Python in this class, and that's an interpreter. But still kind of keeping it pretty general. Uh, there's lots of high-level programming languages out there. This is just a handful of literally thousands, if not millions, of programming languages out there. You got C, C++, JavaScript or TypeScript, C Sharp, Rust, Lua, SQL, and then Python. These are just a couple that I'm familiar with. And kind of a question that I ask my students a lot is, why has there not become one universal language that rules them all? And I think the answer to that is that each of them has their own strengths, things that they do well. Maybe certain types of jobs are easier to code in each of these programming languages. And I really don't think there will ever be a universal language. There's some more popular ones, but not one and then the others all go away. So in this class, like I said, we're going to use Python, and just a couple reasons why I think that makes sense as a learning language for you and your students when you're teaching this in the classroom. The things that it does well, the thing that it does best is the readability. So pretty much everything else in Python is second to this. So they always emphasize readability. Of all the programming languages, this is probably the one that's most English-like. Used in tons and tons of industries, especially AI, not just generative AI, but general purpose AI. Um, there's a pretty well-known ranking system. You may want to Google it, the TIOBE index. Idea here is that they survey Fortune 500 companies and ask them of all the software projects that are going on right now, what languages do you use? So it gives you kind of a month-to-month idea of what's popular and what's going up or going down in popularity. And pretty consistently, Python is near the top or at the top. C, C++ are two other popular ones. So that tells us that if you do put in the effort and the time to learn Python, it's going to be pretty applicable. It's going to be used in lots of industries. One of the reasons that it's really popular is the language itself is kind of slow, but it can take C modules and call them, and then you get kind of the best of both worlds. You get the really good readability of Python, but also the speed of C, and that's a really powerful combination. We'll actually look at a library called Pygame that's written in a C library called SDL, and you'll see that fastness firsthand. Another plus that Python has is it's free, and there's actually two types of free in the software development community. There's gratis, which means that you can get it for no charge, but it can also be open source Libre, as in somebody can get the source code for Python. They could tweak it to their liking and then repackage it as something else. So Python has both of those. Some other software tools will only be one of those two types of free. Okay. Does have some negatives too. So it is slow, and every time that Python is released, they always kind of claim that this is going to be fixed in the next iteration. So we're at 3.14 when I'm writing this. 3.515 is supposed to have changes to the global interpreter lock, the just-in-time compiling. These are two technologies that, in theory, could speed up Python quite a bit, but it always seems like it's one iteration past where we are. So don't hold your breath on either one of those. It's mostly single-threaded. If you're not familiar with the term, it's just modern CPUs have multiple cores, can do multiple things at one time, but Python is only able to take advantage of one of those. So that may be something that changes in the future, but right now it's kind of stuck with single threadedness. But all those things together, I think it's a really, really good learning language, uh, used in a lot of industries. So time is definitely worth it to learn Python. Okay, so that's it for the first lecture. Next one, we will look at how we set up some of the tools that we're going to use to interact with Python. We'll also, might seem like a little odd choice, but we're going to look at command line skills. They're, I think, important to understand what's going on underneath the hood. And that'll be coming shortly. See you then.